So in this video here I've got two equations very similar, and they've got hyperbolic trigonometric functions in there. 2 tanh of x equals cosh of x, 2 tanh of x equals sinh of x. Now I'm going to start with this one first and try and solve it, and then let's see how we go. So 2 tanh of x equals cosh of x. Well, tanh of x, let's just write down the identities as we go along. That is sinh of x over cosh of x. So let's rewrite that as that. So 2 sinh of x over cosh of x equals cosh of x. So yeah, that's a great start. So now let's get rid of this fraction as you would normally do in any other equation. Multiply both sides by cosh of x. So I've got 2 sinh of x equals cosh squared of x. Okay, now would be nice if we had everything in terms of sinh of x or cosh of x. Well, as I've got cosh squared of x, there's a nice identity for cosh squared of x I could use. So cosh squared of x is the same as 1 plus sinh squared of x. So I'm going to plug that into there and let's go from there. So now I've got 2 sinh of x is 1 plus sinh squared of x. So now I've got everything in terms of sinh of x. So now I've got sinh squared, a sinh and a 1. So I've got what could be termed as here as a quadratic in terms of sinh. So if I let y equal sinh of x, I can now rewrite this equation, bringing this onto this side, so kind of flipping the sides. So y squared plus 1 and then minus 2y. And then as everything's over onto one side, I've got to set that to 0. Then this is a nice quadratic we can solve. So here I've got basically 1. If y is 1, that's the only solution I've got, but it's a repeated solution. So minus 1 squared is 0, in which case y equals 1. If y equals 1, then sinh of x equals 1. So to get x out of there, do the arc sinh function. So then x equals arc sinh of 1, and turning that into logarithmic format, I can say x equals natural log 1 plus the square root, whatever that input is, squared plus 1, which will simplify to x equals the natural log of 1 plus square root of 2. So that one solved. I'll be happy with that as my answer. That's good enough. Now let's have a look at this one. So let's try the same technique here. So 2 sinh over cosh, and that equals sinh of x. Right, now what about if I flip things over, bring the sinh to here and the cosh to here? That would be legitimate. So now I've got sinh of x over sinh of x equals cosh of x. And now all I've got to do now is just turn that into, well, sinh over sinh is 1, so 2 equals cosh of x. So 2 equals cosh of x, in which case x equals the arc sinh. So if I do cosh to minus 1 of 2, then that will become, using the logarithm form for cosh, so x equals the natural log of 2 using that input plus the square root. This time I use that one squared and then subtract 1. So then x equals natural log of 2 plus root 3. And that is the wrong answer. That does not work. We cannot do that. So this, don't be tempted by that. So what we got here, we've got sinh of x on the denominator. Now what we can't do with sinh of x is divide by it if we don't know what it is, because we can't divide by 0. So if x equals 0, that we can't do. This side, we can do it. This is correct. Cosh of x is never 0. The minimum value for cosh is 1 in real terms. So that is the correct way. This is the wrong way. So now I'm going to show you a way to do this using a different format to the way we did this one. Okay, so now let's concentrate on this and let's see if we can do this without breaking any algebraic laws. So what I'm going to do now, I'm going to turn these tanh and sinh into their exponential identities. So what we need the sinh and the cosh, and we can derive the tanh from that. So sinh of x is e to the x minus e to the minus x over 2. And cosh of x is almost the same, except we change this to a plus. So cosh of x is e to the x plus e to the minus x over 2. So that's that one. Now sinh of x over cosh of x gives us tanh of x. So to divide these two by each other, I can derive tanh of x. So let's just convert all of this equation here now into its exponential identity. So let's come over here because I might need a bit of space. So tanh of x, that's sinh of x. So if I have 1/2, let's bring the half out, and then I've got e to the x minus e to the minus x, and then divide that all by the cosh one. So again, I've got another half, e to the x plus e to the minus x. So you'll see here, this here will never be 0, because that will approach 0 as x gets larger, but this will get bigger. So that would never be 0. And if x is 0, we've got a 1 plus 1 situation. So that's legitimate. Okay, right, let's just bring these brackets out a little bit more. And then sinh of x, well, we just need to put that one in. So we've got 1/2 and then e to the x minus e to the minus x. So I'm going to leave it in that format. Okay, now let's just tidy up this tanh of x. It looks a bit of a mess, doesn't it? So the halves will cancel. And what I could do is, while I'm at it, I could get rid of this half here by multiplying both sides by 2. So I'm going to do both in one step. So now I've got 4 times e to the x, let's put that times there, minus e to the minus x, e to the x plus e to the minus x equals e to the x minus e to the minus. Okay, so that's taken care of. Now let's distribute the 4 and multiply both sides by this to try and get rid of this fraction. That would be a good idea. So distribute the 4 here. So now I've got 4e to the x minus 4e to the minus x. That takes care of that. And then that will be divided if I multiply both sides by that. And then on this side, I now need e to the x plus e to the minus x, e to the x minus e to the minus x. So that's that. So I've got myself a little pair of brackets here to FOIL out, and I've got this one taken care of. So let's concentrate on this one for the moment, and then we can just leave that as it is for now. So e to the x, e to the x, e to the 2x, e to the x times minus e to the minus x, that's going to give me minus 1. Then here I've got e to the minus x times e to the x, that's with a plus, so I'm going to get plus 1. So that's handy, they will cancel out. And then this one times this one with a minus, I'm going to get e to the minus 2x. So now I've got myself what looks like a difference of 2 squares situation, which is quite nice. So now 4e to the x minus 4e to the minus x equals e to the 2x, and then they cancel, minus e to the minus 2x. Okay, well, got e to the x, e to the minus x, e to the 2x, e to the minus 2x. Difficult to make some kind of substitution as I did here, unless I got rid of this minus 2 power. So if I multiplied through by e to the 2x, I could eliminate that, and then always have positive powers of e to the x. So let's do that. So if I just put one big bracket around the whole thing and times by e to the 2x, that will then eliminate all my negative powers of the exponential function. So let's go through it. So 4e to the 3x minus 4e 2x minus x, that's just going to be x. And then this one with this one, e to the 4x. And then this one with this one, that'll just become 1. Okay. Right, so I've got everything now in terms of e to the 4x. So I'm going to do a substitution just like I did here. Now instead of using y, I'm going to use z this time. So let's just use a z. There's no reason why I can't use a z. So if I let z equal, this time not sinh of x, I'm going to use e to the x. So if I just write up here, z equals e to the x. So then I've got 4z cubed. E to the x, that's just a z, so that's minus 4z. And then here, z to the power of 4. And then minus 1. No z needed for that one. So now I can do the same as I did here, get it all on one side and see if I can solve this equation. So bring everything over. I've now got z to the 4. The z cubed, bring that across, so it's minus 4z cubed. The 4z can come across, that gives me plus. And then the minus 1's on the right side, and that's all set to 0. So we now need to try and solve this quartic equation. So it's not obvious straight away if there's how to get all 4 solutions. Obviously it's a quartic, there's going to be 4. But look at my coefficients. I've got a minus 4, a plus 4, a minus 1 and a plus 1. So that means 1 somewhere will be a solution. So let's write up here z equals 1. So that works. So if I plug in 1, 1 minus 4 plus 4 minus 1 is 0. That's all good. So if plus 1 works, what about minus 1, as I've got a full power and then the odd powers here? So that become plus 1. That will become plus 4. That will become minus 4. And that become minus 1. So minus 1 works as well. So straight away, I've got 2 of my solutions. So if I wrote those out in polynomial form, I'd have z minus 1, z plus 1. And a bit similar to how we did with this here, it's a difference of 2 squares. So I'd have z squared minus 1. So with the z squared minus 1 taken out of it, what I can do now is polynomial long division, subtract it with this, then I'll get the rest of what's left, which will appear to be a quadratic. So let's make a bit of space up here and let's take care of that. Okay, let's do the polynomial long division on this. So z squared into z to the 4 gives me a z squared. So let's write that above here. Put the z squared back into this. So I've got z to the 4 minus z squared. So minus z squared. And that's all subtracted. Now that subtracts to 0. Minus 4z cubed minus nothing just leaves me minus 4z cubed. And 0, got to use this 0 here, minus z squared. That gives me plus z squared. And then bring these down, 4z minus 1. Okay, right, now what we got here, z squared minus 4z cubed, well that gives me a minus 4z to go up the top there. Minus 4z times z squared gives me minus 4z cubed as required, and then multiply that with that, I've got a plus 4z. Okay, so again, subtracting, they disappear. Z squared minus nothing gives me z squared, and then I've got plus 4z minus a plus 4z, that gives me 0, and then minus 1 minus nothing is minus 1. So again, z squared into that just gives me a plus 1, and then bring that back in, I've got z squared minus 1, and then that all cancels out. So that's our solution for that. So let's clear that off now, and then let's put our polynomial format for this z to the 4. Okay, so now we've got a polynomial here from this polynomial here. So that's all taken care of. So this we know is z plus 1, z minus 1. So we need that to get our solutions. All we need to do now is try and solve this for each z. So let's just do some calculation here. Let's take the square. So we'll have z minus 2 squared. That'll be fine. Take off 4 and add 1, set it to 0. So then we'll have z minus 2 squared equals, take that to the other side, I'll have plus 3. And then I'll have z minus 2, take square root by sides. Z minus 2 equals plus or minus square root of 3. And then bring the 2 on the other side. I'll have z equals 2 plus or minus square root of 3. So then here I've got z minus 2 plus square root of 3 and z minus 2 minus root 3. So that's all of my solutions there. Let's make that 2 not look like the z that's next to it. Okay, so let's just rewrite these out a little bit better. So z plus 1, z minus 1, z minus 2 minus root 3, and z minus 2 plus root 3. There we go, a little bit easier to read. Right, but what is z? Z is e to the x. So now I need to set e to the x equal to all of these. So e to the x equals, well in this case, minus 1. E to the x equals plus 1. Then this side we've got e to the x equals, well let's take it on the merit of both its results, 2 plus or minus root 3. So that would take care of that. Okay, so now what can we got here now? So we got e to the x equals minus 1. Well this, there is no solutions. E to the x is always positive. So let's just write that over here. E to the x is always greater than 0. Okay, e to the x equals 1. Well, the solution to that is only when x equals 0. So here we have a solution, x equals 0. And what do we have here? E to the x equals 2 plus or minus root 3. So if we take the log on both sides, x equals the log of 2, let's make that nicer, 2 plus or minus root 3. So is root 3 when subtracted from 2 negative? Well, root 3 is about 1.7, so that will still be positive. So our three solutions are at x equals 0, x equals the natural log of 2 minus root 3, and x equals the log of 2 plus root 3. So that is our final answer and how to solve for this one. Okay.